Alright guys, for homework assignment 15, we already have the bulk of the code here, but we need to fill in these functions. Input O2, which is supposed to be the amount of oxygen they type in, input temperature, and then a calculation function. So specifically, we're going to look at this input temperature one. Because if you can do that one, then you can do input O2. So, what is the function supposed to do? Prompt the user to enter a number of grams of O2. The input must be greater than 0. We will loop until good data is entered, and then return the temperature. So there's more than one way of looping to get good data. I'm going to demonstrate two different ways. Here's one way. It's just called a while true loop. What you do is you write a loop that just sits there and repeats infinitely, except we're going to put a break or a return statement in there so that it really won't loop endlessly. So let's see, input temperature in C. We'll do that one. Define input temperature in C. Change the font size to make it easier to read. So what are we supposed to do? We want to ask the user to type in a value, and we want to get that value, and we want to return it. It probably should be a float. No reason to force them to type in whole numbers. So here's what it would look like if we weren't doing any error checking. Print, please enter a temp in degrees C. And we could use our input statement. T is equal to input. Then we can convert that to a float, like that. And then we could return T. Now that'd be great, except the requirement was the input must be greater than minus 273.15, because that's absolute 0. We're not really a physics class or a chemistry class, but we don't want to allow the user to type in values that are below absolute 0. That will break the formula. So what we are going to do instead, and by the way, we could change this a little bit so that it could be done in one single line of code. And the book tends to demonstrate things like this, where we put the print inside the input, like this, where we put the input inside the float, like this, there we go. That one statement replaces these three statements. I don't know which one you like better. I actually like seeing them broken out like this usually. But this also works just as well. So I'm just going to pick one and run with it. I think I'll go with deleting that method, deleting that one, and keeping these. Okay, so what we want to do is we're going to put this in a do loop, in a while loop, while true. This means just keep repeating infinitely until we get some good data. What is good data? When it's greater than 273.15. So if the temperature entered is greater than equal to 273.15, then we return true. Then we return the temperature that was entered. Else we don't do anything. This will loop infinitely until they finally give in and type a good value. Now there's a couple of other things we could add here. We could do a sanity check to make sure that the data that they entered actually was numeric data, that kind of thing. So this is good enough. That's one way of writing it. Here's another way, without using a while true. You can get the input with what's known as a priming read. And here I wish that I had chosen instead to do it with that single line rather than the 3-line approach. But anyways, now we have our approach. If it's a problem, then we go into our while loop. While the temperature is less than 273.15, we're going to print an error message. Which this did not actually handle, this method up here. Anyways, I'll go back and add an error message to that. So, if the temperature they entered is too low, then we will print an error message. We could even tell them what it has to be, you know, if we wanted to. Something like that. Then we want to ask for it again. And then when they finally do get a valid temperature in there, then we return it. I like this method, the while true, simply because it gives shorter amount of code, and to me it's less complex. Just keep repeating until we get valid data. This is another very common way, and it's a way that a lot of textbooks show it. You use what is known as a priming read. You get your initial stab at the data, and then if it's great, awesome, you just return that value. But if it's not great, we check the error condition, and if it's in an error state, then we loop until they finally enter some data that's not in an error state. Both of those would work for input temperature. I'm going to prove it by naming them input temp in C1 and input temp in C2. This one did need an error message, so I'm going to put an else here, print error value too low, print must be greater than or equal to 273.15, like that. Now this looks a little bit nastier, but hopefully it's still clear. Now that I think about it, I think I will reword it just a little bit. I'm going to make it say if the temperature is less than 273.15, then print our error messages. Else, there we go. To me, that looks better. I think that the return ought to be broken out like that. So it's the last thing in the loop. Makes it easy to spot what it's doing. You could also use a break statement. A break statement will exit the while loop, but it won't return out of the function. So then we'd have to put a return down here. Either one works. Whichever one looks simpler to you. I think for this case, I'm going to move that return back to where it was. And there we go. We have a looping function that forces the input to be greater than our threshold value, our boundary condition. And we've implemented it in two ways. So let's make sure it works. X is equal to input temperature in C. We're going to call the first one first, and then we're going to call the second one. Then we'll just print them both out. Make sure they work. I'm going to call my function input temp. Now we're ready to run. Oops, I have an error. I left off my colon. There we go. Give it another shot. Whoops, I left off my colon again. I'm thinking in terms of Java and C++ languages that don't require colons to start your loops. All right, here we go. Enter a temperature in C. I'm going to enter a bad value, -1000. It says error, value too low, must be greater than. I'm going to give in, enter good data. Whoopsie. That should have been less than negative 273.15. I cannot believe that I put that error because that's a condition. It should not accept any values less than negative 273. So that was dumb, but easy to fix. Run again. Enter bad data first, negative 300. That worked, actually. We didn't get an error message, so that means it worked its way through the method. But we didn't want that to go through without entering an error. I've made a mistake somewhere. Negative 300 is bad data. Why did that accept it? So the problem was I was extraordinarily careless. If I want to convert a number to a float, I have to pass that number into the float function. I have to pass a string into the float function. And I did not do that here either. So by winging it, I had several errors, but that's okay. That's fairly common in the development process. Run it once more. I want negative 300 to fail. It says error, too low. I want 0 to be okay. It worked. The next one. Anything below 273, negative 273 is an error. It gave me an error message, so when I type in another value, it's good. So why did I get zeros and zeros when I printed those out? Because when I fixed the float call here, I did not fix it here. That's another example for why I do not prefer using the priming read technique for data validation. So I strongly recommend doing it this way, just for the reason you saw. Why? Because here I have code duplicated. I have code that looks identical in both of these spots. And sure, I could change these so that they were just one line of code, but still, it's duplicated code. So I prefer this one because that code is not duplicated. It's just right there. This one makes more sense to me. Whichever one makes more sense to you is fine. And there we go. It printed out some successful data. So that is our input temperature in C1 function. Excuse me, just input temperature in C. The rest, this is stuff that I would just comment out. I don't need this anymore. Comment out region. There we go. So the other one, input O2, it's pretty much exactly the same. It just needs to print out a different message. Prompt the user to enter a number of grams of O2. So ask for that rather than a temperature in C. And instead of checking for negative 273.15, check to see if the value is greater than 0. So this is a real easy function to write now that we've already written this one. It's just a few changes. Change the name of it. Change the print message. Change the lower boundary from negative 273 to 0. Change that error message, and you're good to go. You might change the variable name as well because T doesn't make all that much sense if you're asking for grams, but whatever. Okay, I hope that helps.